Take a risk. 1, 2, 3, 4, 5. Four.
You said binomial because the probability is the same for each question.
Okay. Go ahead. Keep talking.
One question is like one trial.
So how many trials do they have?
10.
10 trials. Probability of success is is it 1 out of 4?
Yes.
And then Q?
3 out of 4.
3 out of 4. And it never changes because, like, suppose that you're like, if you go into a quiz and you're randomly guessing, like you've never taken this material before, you don't know what it is, you're randomly guessing, you have a 25% chance of success every time. It's not going to be like, oh, I've been doing really well in this quiz, so now my percentage is getting better. No, one question doesn't affect the other. Of course, it would affect it if you studied. That's the whole point of studying. Go get a prize. Nice job. All right, next page. All right, binomial probability formula. We are going to take this nice and slow. And you know what? I think I'm going to give a pen away to somebody who can do this. I haven't done that in a while. What colors do I have? Okay, I have dark blue, purple, like a maroon, bright red, pink, dark green, and light green. A lot of cool colors here. Okay, so this is a hard thing to figure out, and I'm going to take it nice and slow. So let's say that we were trying to find the probability of you getting 3 questions right on a 4-question test, okay? So I'm going to help whoever wants to do this. It's a 4-question test. Let's say that you've got a 1 in 4 chance of getting it correct, okay? So there are 4 questions. I want 3 of them right and 1 of them wrong. What are the chances of that happening? Somebody want to risk it and start talking me through this? For a pen? Come on, be brave.
Wait, you said 3 right?
3 right out of 4. Okay, Mason, do it.
So would it be, so if you need 3 right, the odds of getting 1 right would be 1/4.
Right?
So you do 1/4, 1/4, and 1/4.
Okay.
And then,
So you're basically saying I've had 3 successes right here?
yep,
Okay?
and the odds of you getting 1 wrong are 3/4.
Okay. So I'm going to start writing this. This is the probability of X equals, we start with, you're saying success to the number of successes we want. So like here, it'd be 1/4 to the 3rd power because we want 3 successes, right? And then times Q to the what? If I want 3 successes, how do I know how many failures I want? 1. Well, in this case, it's 1. But is it always 1? No, because this could be 2 or something. So what is this number right here? What letter is that? How many trials do we do? Do you remember from the first page, Mason? Look in the first page. How many trials? What letter is that?
A fixed number of trials?
No, man, like what letter? Like A, B, C, D, E, F, G. We have a letter that represents the number of trials. N. So this would be up here, n minus x, because you take the number of trials and you subtract the number of successes you want. Now this isn't quite done. And here's the problem, Mason, and I'm sure you can kind of guess this. This is only the probability of the first 3 being successful. But what about the last 3? What about the first 2 and then the last one? You know what I mean? Like there's many different opportunities. So how do I pick out of 4 things, 3 things in a certain, how do I pick which questions I'm gonna do? Basically, like, I need something to say, I only want 3 questions, what are my possible options? It's something we did last chapter.
Would it be, it'd be like I don't know what it was called, would it be like one of the NPR things?
Yes,
Like
but it's NCR because order doesn't necessarily matter here. Like, imagine if I had a hat in front of me and I had 4 questions in it and I labeled them the first question, the second question, and the third question, the fourth question. Basically, I'm just saying which of the 3 am I going to get right. So I'm choosing 3 of them, and it doesn't matter what order I pick them out of the hat. Whether I pick 3, 2, and then 1, doesn't matter as long as I know which ones I'm picking. So this is here, n choose, so times n choose x. And that's the whole formula. So this is success here, if you want to write it out. This is the success, this is the failure, and this is the which ones, essentially. So this is the probability of success, this is the probability of failure, and this is you figuring out which ones you want to be successful on. Nice job, Mason. Good job taking a risk.
I knew there was gonna be something with like the Q doing something minus something.
Mhm.
But, just figure it out.
Okay, so now I'm going to show you how to do this, and we're going to do this nice and slow. There's actually 3 ways you can do binomial probability. You can do it with a formula, you can use it, your calculator has a way to do it by itself, and there's a table in the back of the book, and I'm going to teach you slowly by doing all kinds, okay? So let's go down to example 3, because we're going to start with the formula ones. It says a card is selected from a standard deck and replaced. The experiment is repeated a total of 5 times. A success is selecting a club. When making your chart below, fill out the probability. Okay, so we've got, you could get, let's see, there are 5 times. So you could get 0 successes, 1 success, 2 successes, 3, 4, or 5. So imagine that I've got a deck of cards in front of you, and I say, look, a success is pulling a club. And I say, pick a card. And you pick a card, and then you put it back, and I shuffle. And you pick a card, and I put it back, and shuffle. And the putting it back is important because that's what makes it binomial, because the probability of success doesn't change. Okay? And we see how many clubs you get. So what are your chances of getting this? How many, what do you guys think? What's going to be the highest probability? If there's 5, one or two clubs, you think? Okay. Do you think it's really more likely that I'd get 0 clubs or 5 clubs?
0.
Okay.
Would it be the same?
Let's find out. Okay. So what do you think, Thomas? Oh, I thought you were saying
For
something.
which one?
For like, do you think it's more possible for 0 clubs or 5 clubs? To draw 5 clubs in a row or 0 clubs in a row? 0? How come? Because there's 4 suits, yeah. And it's more likely to get, so like it would be equally likely if this was a 50-50 shot, but it's not going to be because there's more not clubs than there are clubs. But we'll find it out. Okay, it says here that we're going to do probability of 0 and probability of 3, so this is probability of x over here. Using, this is going to be our work in the middle, by using the binomial theorem.